Chaudhary and you are watching Uttam Studies. Today in this video we discuss about the jaundice and the metabolism of jaundice. So before watching the video, please like, share, comment and subscribe my channel and press the bell icon to get the notifications. Thank you. So now we are going to start our topic. The topic name is jaundice. Jaundice. In this video, we discuss about what is jaundice, from where this word derived, or you can say originates. What is the origin of this word, and what happens in this? What happens in this, and how it affects human body, and what is the pathophysiology of this, and what are the causes, and or you can say what are the risk factors of jaundice, and what are the sign and symptoms of jaundice, and what diagnostic evaluations are done to evaluate the jaundice. And next we study about the management of jaundice. Medical management is used to treat the jaundice. And next but not the last but not the least, that is prevention. How we can prevent this jaundice. These all things we discuss in this short video. First we discuss about what is jaundice. Jaundice is this is an English word. This is an English word which is derived, or you can say it's taken from a French word that is jaunir. This is a French word. This word means yellow. And this jaunir word is also taken from another French word that is jaundice. This is also a French word which means yellowness. This jaundice means yellowness. From here we get an idea that in jaundice yellowness occurs. From here we get this point. So now we study about this, that how this yellowness occurs, why this yellowness occurs in our body, what is the main cause of this yellowness, and where it occurs in our body. So this yellowness is due to the deposition of a yellow pigment under the skin. So here we get a word that is yellow pigment. What is this yellow pigment? This is the question. What is the yellow pigment? This yellow pigment is a compound known as bilirubin. This is the main cause of yellowness in the jaundice. The yellowness occurs due to this compound, this bilirubin. So initially it starts from our skin. This is my hand. And this is eye. Initially, this yellowness starts from skin and from our eyes, then to other body parts. So from all these things, here we get a definition of jaundice. The definition is, it is a medical condition in which yellowing of skin, or you can say eyes, occurs due to excess of bilirubin. This is a small definition of jaundice. In in normal language, we can see like this, that it is a medical condition in which yellowing of the skin and eyes occurs due to the excess of bilirubin, or you can say yellow pigment. In here I discuss a point in medical terms. In medical terms, jaundice is also known as icterus. Means a word icterus is also used in medical. So now you ask about this, that what is this bilirubin, from where this comes, and how this gives yellow color to our body, and how this causes yellowness in our body. So here we discuss about bilirubin, because this is the main culprit of jaundice. Okay, so bilirubin. Now in this video we discuss about what is bilirubin, from where it comes, what its normal value in our body, how it increases, how it decreases, and how it affects human body, and how it is metabolized in our body, metabolism of bilirubin. These all things we discuss here. Now we discuss about the metabolism of, you can say, metabolism of bilirubin. Metabolism of bilirubin, or you can say pathophysiology of jaundice. Pathophysiology of jaundice. So before starting the metabolism, first we have to know that from where this bilirubin comes. This bilirubin, I will discuss here about the metabolism here in the whole page, because metabolism is a very big topic. So here we discuss about metabolism of bilirubin, or you can say pathophysiology of jaundice. This is our, we start from here, that from where this bilirubin comes. This is our bone. Is my bone looks like a bone or not? And in bone marrow, you all know that bone marrow is present, and our bone marrow contains some hematopoietic stem cells. What is hematopoietic stem cells? Which get differentiated into early erythroblast, which differentiate into erythroblast, and erythroblast then after differentiated into early erythroblast, in which stage the ribosome synthesis occurs, and then the early erythroblast get differentiated into late erythroblast, in which the ribosome synthesis a lot of hemoglobin. So the late erythroblast contains a lot of hemoglobin, and then the late erythroblast get converted into normoblast, which have a lot of hemoglobin in it, and then this normoblast get converted into reticulocytes. This also contains a lot of human hemoglobin. Here this is our, this whole process is known as erythropoiesis. Means the formation of erythrocytes, or you can say red blood cell, is known as erythropoiesis. So Here, reticulocytes enters in our blood vessel. These are our blood vessel. Okay. Blood. Here this is reticulocyte, which contains a lot of hemoglobin. And after 1 or 2 days, in blood vessels, it get converted into red colored erythrocytes. You can say erythrocytes, which is the end product of this process, erythropoiesis. These erythropoiesis are also known as RBC. You can say red blood cell, which contains a lot of hemoglobin, which is responsible to carry oxygen to our body organs or body parts for their survival. So here, this erythrocyte doesn't remains in our body for a lifelong time. It have its expiry date. You can say everything have its expiry date. This erythrocyte have also expiry date of approximately 120 days. After 120 days, it dies. So after this, we study about here we can add another point, that these erythrocytes are anucleated. Erythrocytes are there is no nucleus in these erythrocytes. So after, if they are damaged by any disease condition, or if they are damaged, then, or if they dies, means their life period is completed, then after, our immune system or our body have to remove these damaged and died erythrocytes. So here is our spleen. I really don't know how to draw spleen. This is spleen, not kidney. It looks like kidney, but it is spleen. And here is our bone. And here is our liver. This is our liver. These damaged and dead RBCs goes into the spleen. As you all know that spleen is the graveyard of RBCs. Then after goes into there are many phagocytic cells are present in the liver, in the bone, and in the spleen, known as macrophages. These are macrophages, which engulf these damaged and dead RBCs. Here, this is damaged or dead RBC. Then here its degradation starts in the macrophages start to degrade these RBCs, and this release hemoglobin. Here this release a lot of hemoglobin, and then after further degradation, this hemoglobin get converted into heme and globin. This globin further reused in the erythropoiesis process. This is again reused. So now the heme remains. This heme is again relieves unconjugated bilirubin. Degradation of heme occurs, which then after unconjugated bilirubin and iron, you can say Fe+3, are formed. This iron again reused, goes to the system and reused in the erythropoiesis process. Okay, now the whole thing starts from here. This unconjugated bilirubin. This unconjugated bilirubin is very toxic. Is very toxic to our body, and it is a lipid soluble molecule. Lipid soluble molecule. It is a lipid soluble molecule. So this requires a protein. This requires a protein to travel in our blood. So here you ask that which protein is required to carry out this unconjugated bilirubin. Here is albumin. With the help of albumin, this unconjugated bilirubin travels in our blood. Here I draw a blood vessel. This is blood vessel. This unconjugated bilirubin goes into the blood, unconjugated bilirubin, and here albumin is attached to this. Albumin works like a passenger for this unconjugated bilirubin, and when it goes to the portal system, it goes into the liver. This is our liver. It goes into the liver via the portal system. This albumin is detached in the blood. Now here this unconjugated bilirubin is here. As you all know that the liver have its own phagocytic cells that are Kupffer cells. You all know that liver have its own phagocytic cells that are known as Kupffer cells. These Kupffer cells are also, as earlier here I discussed that dead and damaged RBCs comes in liver, and here these Kupffer cells engulf these dead RBCs, and here again the degradation of RBCs start, and hemoglobin is released, and hemoglobin broken down into globin and heme. This globin again reused in the process that is erythropoiesis. Here that is erythropoiesis. Okay. Now this heme again degraded and converted into first is unconjugated bilirubin, and another one is iron, that is Fe3. As earlier I discussed that this iron is also used in the process that is erythropoiesis. Okay, here in the liver, again the metabolism of unconjugated bilirubin occurs. Here this unconjugated bilirubin get converted into conjugated bilirubin with the help of glucuronic acid present in the liver. Sometimes this glucuronic acid also becomes the cause of jaundice, because if absence of glucuronic acid may leads to increase in the level of unconjugated bilirubin, because it does not convert it into conjugated bilirubin. Now from here we get a thing that is conjugated bilirubin. This conjugated bilirubin is not that much toxic as I discussed about unconjugated bilirubin. This conjugated bilirubin is water soluble. soluble, so it can be excreted by liver in the bile salts, with the bile salts. So here I draw a gallbladder from this. This is cystic duct, hepatic duct, and common bile duct, and a pancreatic duct also. This is common bile duct. In this pancreatic duct also meets. Then after this, conjugated bilirubin goes in the common bile duct with the bile salts. And as you all know that this common bile duct opens in the duodenum. That is a part of a small intestine, at a point where it enters is known as sphincter of Ori. So here this is conjugated bilirubin. As you all know that this is water soluble, so it travels in the small intestine. Here I will draw a small part of large intestine. This is appendix. This is rectum and anus, and here is our, you can say, small intestine. This is large intestine, and small intestine enters into the large intestine. So this conjugated bilirubin travels, as it is water soluble, so it travels into the small intestine. Then it comes at the last point of small intestine, or you can say the starting point of large intestine. Here this conjugated bilirubin is converted into urobilinogen. That is urobilinogen in the presence of intestinal bacteria. With the help of oxidation reaction, in which glucuronic acid is detached and again reused, goes to the liver and again reused. Then after this, urobilinogen travels in the large intestine, urobilinogen. And here, as you know that this urobilinogen is also lipid soluble, so this again converted into stercobilin. This is water soluble, so this can be easily excreted. 85 to 90% converted into stercobilinogen, and about 10% of this urobilin is again reabsorbed by the system. Here it is urobilinogen. Then after from here, this 10%, again 5%, about 5% again participate in enterohepatic urobilinogen cycle. Here it is, this 5% enters into the liver and participate in enterohepatic urobilinogen cycle, in which it is taken up by the liver and resecreted into the bile. Again this process starts, and in this again remaining 5% goes into the kidney via the blood, again goes into the kidney. This remaining 5% of urobilinogen goes into the kidney, where it is converted into urobilin, which is yellow in color. And again this is water soluble, so it can be easily excreted by the kidney, so it with the urine, so this gives a yellow color to the urine. So this is about the 10%. Now this remaining 85 to 90% stercobilin, it is also a water soluble product, so it is transported in the large intestine, then in the rectum, then anus, and then it is excreted in the form of feces, with the feces, and it gives a brown color to the feces. So from here we get an idea that if the metabolism of this unconjugated bilirubin occurs, then at the end yellowing of the yellowish orange, you can say, a color of the urine occurs, and brownish color of feces occurs. This is all about the metabolism of bilirubin. From here we started, and this is. So this you have studied about this. Now again we come at here. We studied about the pathophysiology of this. Now we discuss about the causes and what are the risk factors. Before studying these causes and risk factors, we go through a little topic about the types of jaundice. There are 3 types of jaundice. First is prehepatic jaundice. Second is hepatic, or you can say hepatocellular jaundice, and third is post-hepatic jaundice. In from these words you can get their definition. In pre-hepatic jaundice, if there is problem at here, if there is more degradation of RBCs occur, then a lot of unconjugated bilirubin is formed. So there is a lot of unconjugated bilirubin to be the liver have to metabolize this, so the liver get loaded. So this is very hard for the liver to convert this unconjugated bilirubin very fastly, as it produced very fastly. So if the problem is here, this is prehepatic. Now second is hepatocellular. By the name we can get this, the hepatocellular. If there is problem in the cells of liver. Up now you can ask that what are the problems? What problems? If there is a liver cirrhosis, or you can say damaged liver cells, they doesn't work efficiently, and if there is tumor in the liver, or you can say any other liver diseases, these are all are the, or you can say hepatitis is also the cause of this jaundice. So these are hepatocellular. Then the last is the post-hepatic. If there is any blockage in the in the cystic duct, or you can say common bile duct or hepatic bile duct, if there is any obstruction or tumor in this, you can say if there is gallstone or obstruction in all these things, then there is a difficulty of conjugated bilirubin to pass in the duodenum. So these are the post-hepatic causes of this jaundice. So now we discuss about the causes and risk factors. By these types, we already discussed about the causes and risk factors of this. The causes are, first, if in babies, first is premature birth. Now you ask that how premature birth may lead to jaundice? Because in premature babies, their liver is not fully matured. Their liver is very immature, so there is difficulty in the liver faces many difficulty to convert the unconjugated bilirubin or metabolize the bilirubin. Now third is breastfeeding. Now you ask, why breastfeeding is the cause of jaundice? Sometimes, not always, sometimes breastfeeding may also causes jaundice. A physiologic jaundice may occur if there is not sufficient breastfeeding. So the treatment of this is, we does not have to stop the breastfeeding. We have to continue the breastfeeding. Next is hepatitis. Hepatitis is also a cause of jaundice, because in this the cells of the liver are damaged. And next is gallstone or any obstruction in the cystic duct or bile duct or common bile duct. If there is any tumor, this is all these things, or any liver diseases, or you can say autoimmune disorders. These all are some, or you can say fatty liver, or you can say alcoholic liver diseases. These all are many causes. These are simple, mainly these are the causes of this. Now we discuss about signs and symptoms and diagnostic evaluation and management of jaundice, and what prevention we can take to prevent this jaundice. All these things we discuss in the next video. Till that, wait for the video, and thank you guys for watching the video. Thanks a lot.